The objective of this lesson is to have students be able to solve 1- and 2-step problems using a pictograph. They will also be able to describe the process taken to solve a problem. Let's take a look at a pictograph and see what information we can gather from it. Looking at the title, this is a graph that represents the amount of ice cream sold in July at an ice cream store. What is the scale? It looks like 1 cone represents 8 gallons of ice cream. What does a half cone represent? Well, I know that 1/2 of 8 is 4, so a half cone must represent 4 gallons. Knowing the scale, how many more gallons of vanilla was sold than mint chocolate chip? If I look at just vanilla and mint chocolate chip, vanilla has 3 more cones than mint chocolate chip, and 3 times 8 equals 24. So 24 more gallons of vanilla was sold than mint chocolate chip. How many more gallons of strawberry need to be sold to equal the sales of cookie dough ice cream? If I look at just strawberry and cookie dough and I match the cones, it looks like there's 2 more cones of cookie dough than strawberry. So 2 times 8 equals 16. 16 gallons of strawberry ice cream needs to be sold to equal the amount of cookie dough. Suppose you own this ice cream shop and you use the sales from the previous month to predict what the sales will be the next month. Students are given different scenarios and are asked to decipher what the question is asking, what information is needed, and what they need to do to answer the question. Here are a few examples. Vanilla can be purchased in 10-gallon tubs. You are sure you can increase sales by at least 2 gallons. How many tubs should be ordered for August? The pictograph tells me that 6 times 8 gallons, or 48 gallons, were sold in July. If we want to increase sales by at least 2 gallons, then I would want to sell 48 gallons plus 2 gallons, which is 50 gallons. Now I know I need 50 gallons. If vanilla ice cream is sold in 10-gallon tubs, then I would need to figure out how many 10-gallon tubs makes 50 gallons. If I draw a model of this, I'll draw 10-gallon tubs until I reach 50. Here's 1, that's 10. Here's 2, that's 20. Here's 3, that's 30. Here's 4, that's 40. Here's 5, and that's 50. So I would need to purchase at least 5 10-gallon tubs of vanilla ice cream. Here is one more. You plan on having a sale on strawberry ice cream in August. You are hoping to sell an extra 8 gallons. If it comes in 5-gallon tubs, how many tubs will you need? In July, we sold 8 gallons of strawberry ice cream, which is 8 gallons plus 1/2 of 8 gallons, which is 4. So we sold 8 plus 4, or 12 gallons of strawberry ice cream. If we want to sell an extra 8 gallons, that would be 12 plus 8, or 20 gallons of ice cream. Now that I know how many gallons I need to figure out how many 5-gallon tubs that would be. I can count by 5s to 20. 5, 10, 15, 20. It would take 4 tubs to make 20 gallons. When solving multi-step problems like these, students can easily get frustrated and want to perform one step and be done. Guide your child toward approaching a problem one piece at a time, and then revisit the question to be certain each piece is taken care of. You might encourage them to highlight or circle the important information before planning a solution strategy. Using manipulatives or countable objects to act out the problem or drawing a picture is helpful. After completion, it is a good practice to have your child recheck and see if their answer makes sense and is reasonable. In this lesson, students solve 1- and 2-step problems using information from a pictograph. We met this objective by having them use data from a pictograph in a variety of scenarios that required more than one step to the solution.